A study by Clint, Boal, who's with the U.S. Geological Survey, Texas Cooperative Fish and Wildlife Research Unit, Texas Tech University in Lubbock, Texas. And his co-author is Brent, Unity College, Unity, Maine. And the title of their talk is Long-Term Banding Provides Insights to Weather-Influenced Survival and Recruitment of Bananaquits. Clint will present.
Thank you, Joe. I'd like to voice my appreciation for being a part of this symposium. It's been really great to see all these talks so far. And I think what I'm presenting is maybe a little bit of a different perspective on some birds and the responses compared to some of these other studies. So I'm focusing on Bananaquits, and it's an abundant species across the Caribbean. Everybody, loves Bananaquits. They're neat little birds, primarily nectarivorous, and it's pretty well demonstrated that they decline following droughts and following hurricanes. And so one of the compelling questions is, as the prognostications for the Caribbean are increased periods of drought and increasing intensity of storms, and when rainfall does occur, it's going to be more torrential. At least those are the prognostications. And so how is that going to affect these birds? And for orientation, the location I've been working on is a small island in the British Virgin Islands, denoted by the white arrow on this map. And just for perspective, this island is 3.4 square kilometers. And the British Virgin Islands in aggregate, not counting St. Croix because it's out there quite a ways, but in aggregate, there are 289 kilometers total in landmass. A lot of the talks we've been seeing are from like Puerto Rico, they may be from Jamaica, Bananaquit work's been done in Trinidad. And those areas have a landmass of, Jamaica's 10,000, almost 11,000 square kilometers. Puerto Rico is over 9,000 square kilometers. So the area of land is dramatically different. The topography is dramatically different. And the vegetation communities are more limited in the Virgin Islands, where it's mostly subtropical dry forest, except at the very highest elevations, which on the island I've been working on, the highest elevation is about 240 meters. And so this presents, in response to hurricanes, it can present some different impacts potentially to avian species. And this is a aerial view of the island. You can see it's functionally about 5% of the island is impacted by human activities, and the rest functions primarily as kind of a de facto nature preserve. And I've been going there, I went there from 2003 to 2015. From 2003 to 2012, we ran a banding station at an average of about 350 net hours per year. These were always in October. That was when we could go down there. And the focus was primarily on misnetting neotropical migrants, especially black-polled warblers. But we recorded all the data on everything we caught, and Bananaquits were the most common resident species we captured. And so we used those data from 2003 to 2012, and we, to try to look at this impact of weather influences, we used monthly precipitation and temperature data from Chardon de Mailly, which was the closest regularly consistent weather station. It's 40 kilometers away, but it's representative of the Virgin Islands. We calculated the monthly standardized potential evapotranspiration index, which incorporates basically the whether or not you have drought conditions or you have above average precipitation in a given year. And there's more detail to it that I can respond to if people are interested in that or are unfamiliar with it. But it also incorporates temperature. And then we look at all named storms, which would be tropical storms or greater, from 2003 to 2012. And we can, for our modeling purposes, we looked at the paths of those storms and the estimated speed of the winds that fell on Guana Island during those storm passages. And so, a lot of times the storms don't do a direct hit; it's kind of a drive-by. So we looked at we considered just a storm year as when the winds were 63 to 92 kilometers per hour, and then a major storm if the island was subjected to winds in excess of 93 kilometers per hour. Also, while I'm thinking about it, mi español es muy pobre, lo siento, but I tried to do some Spanish text here. If I butchered the language, I really apologize up front. To do this data analysis, we did a nested hierarchical approach, and I have to attribute this to Dr. Brent, my colleague on this. He's the modeler. But we looked at recapture probability initially, and you can see the variables we looked at here was sex, age, year of capture, net hours, and an interaction of sex and age. We took the best model from that to look at survival probability. And these are the variables we looked at: sex, age, time, wing chord, mass. Sex and age as additive and interactive variables or functions. And then we used the best model of that to look at the influence of weather. And we looked at SPEI at several different levels. I want to point out the December to February, which was like the winter months, April to June, which was like late spring, which for Bananaquits, it's, at least a lot of the things I've read, is the ties to precipitation influencing survival and reproduction. I then looked at storms and then an additive model with SPEI and the best storm model. To try to look at population growth, my partner Brent used the cradle approach in MARC, and functionally that's just the typical survival and recapture probabilities with the added in factor of recruitment denoted here by the F. And we considered recruitment as after hatch year birds at time t+1 per after hatch year birds at time t. The nested approach is the same as for the survival models, and then all the converging models were reparameterized with the lambda parameterization. If that means nothing to you, it really doesn't mean a whole lot to me either. I trust my modeling partner on that. But it allows estimation of lambda to look at population growth. And so getting into the results here, we captured a lot more birds, but we included for this analysis 466 individuals that we were able to determine sex and gender on. And we had recaptures on 94 of those. Recaptures may have been just one recapture up to 7 recaptures. We found that sex was the most influential variable on recapture, with a higher recapture rate for males. And we had age and sex both influence survival. With the survival model, there were 2 competitive models out of everything we ran, and those are shown here. And in total, 65% of the weight was on age and sex. So we combined age and sex as an additive or as an interaction for the model looking at weather influence. And then modeling that with storms, major storms, and SPEI, it turned out that the SPEI for winter, this is a bit of an error here. The top 3 models are shown here. It was the storms, major storms, and then that winter SPEI had the biggest effects on survival. And that carried the majority of the weight. Now, looking at this, what it told us is that storms, even the tropical storms, reduced survival by 4 to 7%. Additionally, the SPEI, surprisingly for us, it wasn't the spring SPEI, it was the winter SPEI. Dry conditions from December to February reduced survival by about 4%. And wet SPEI in winter increased survival, or was associated with an increased survival rate estimates of 1.4%. When we put all that together and did the lambda reparameterization, it suggested that in a non-storm year, lambda would be in the positive of 1.11, and during a storm year, lambda would drop as low as 0.76. And so it's pretty obvious that these storms can have a pretty substantial effect on Bananaquit populations. And this is consistent with a lot of the talks that were here yesterday, looking at the idea that they had low resistance to storms, that they had high resilience. And survival was, in our case, survival was also influenced by winter conditions, as I mentioned. Now, one of the things to think about is if you have a low lambda like this, what happens when you have a bowling alley of hurricanes lining up and an island gets hit 2 or 3 times in a year, or it gets hit in subsequent years, and you have that cascading depressive effect on a species. So I think that's a compelling question to try to look at in some of these areas. But one of the things that I had not planned on including in this, and then after the talks yesterday, I wanted to add this in, is that Hurricane Irma and Maria both bullseyed the island I'm working on. And I was told that, Maria was inconsequential because Irma did so much damage, there was nothing left to damage when Maria hit. I couldn't get down there in 2017 after the hurricanes. I couldn't get down there in 2018 even because of the island had so much damage they wouldn't let me come on. But we got down in 2018 and did a post-hurricane assessment. I'm going to try to go through this rapidly, but we looked at multiple lines of evidence to try to assess Bananaquits. And the first one here is captures per 100 net hours. And in the 5-year average prior to the hurricanes that we were misnetting, we had about 14.5 captures per net hour. In 2019, that was just down to above 10. We did a in-season recap estimates for the last 5 years of our effort down there. And we had 14.4, an estimate of 14.4 Bananaquits per hectare. And then in 2019, we had, less than 2 per hectare. We did occupied plots, and these were survey points across the island. Prior to the hurricanes, we had a 61% occupancy in which a Bananaquit was detected on a survey plot. In 2019, we had less than 30%. And then our distance sampling, which I had not done before, but I did it in 2019, and it was 1.2 per hectare, which lines up very well with our within-season recapture estimates. And so this is 2 years after the hurricane. And what comes to my mind in this is that in some of these other islands, you see a real rapid increase in Bananaquits following these impacts. And it may be that there's a factor where it's not so much the reproductive potential for Bananaquits, but that resilience may be more of a factor of the topography, of the forest type, of just the island mass sizes and available refuges for those species. I think these are some really interesting questions to look at, and developing a collaboration to kind of pursue this in the long term would be pretty informative. And I know I'm running out of time with that. I appreciate the people that helped over the years and the Falconwood Foundation for supporting this. And if I have any time left, I'd be happy to try to answer any questions.
Clint, we're out of time, unfortunately, but if we can save some questions for this afternoon, I'd like to pursue some. I can think of a bunch of Bananaquit questions and comments, but that would take
I'd love to discuss them. I'll be here this afternoon.
That'd be great. Hey, nice presentation.